I'm here to talk about Bing Maps. Bing Maps is, of course, the refresh of virtual Earth as we've integrated more and more tightly with Bing. And I'd like to talk in particular about Bing Maps as an information ecology. So to make that a little clearer, what I'm talking about is an ecology of content and of users and of apps. So this is something that hopefully, as I show you various elements of what we've brought together, it'll become clear what I mean. I'm hoping that my internet connectivity, which has been a little bit dicey on the stage this morning, is going to not embarrass me on stage. We think about Bing Maps as a spatial canvas. And what this means is that it's not in itself an application. What it is a surface, and it's a surface to which all sorts of different things can bind. And by binding all of those things, whether they are content or users, images, entities, by binding all of those things onto a common surface, what we do is we provide a way to weave them together into scenarios. We provide a way for the information from one source to really add to the information from another source. And we provide a way for the services, for these kind of underlying canvas services, to be used by applications and scenarios that ride on top. So I'm going to start by giving you a fairly literal sense of what I mean by canvas from the point of view of imagery, since that's one of the major data types that we think about binding. Now, I'm sure that most of you are familiar with photosynth, which is near to my heart, since that's kind of the last project that I did before coming and becoming the architect of Bing Maps. When we first started the photosynth project based on phototourism from the University of Washington, we were imagining that if we started to mine users' photos from the web, from Flickr and from other sources like this, that based only on that sea of photos, we would be able to reconstruct significant parts of the world. And there's something, frankly, a little bit naive about that vision when I look back on it now a few years later. There were some very impressive demos that came out of early uses of photosynth in tourist destinations like Notre Dame. So this is the 3D Notre Dame Cathedral reconstructed from lots and lots of Flickr photos tagged with Notre Dame. And these are beautiful examples, beautiful use cases of lots of imagery, lots of organic imagery binding together into a 3D model. I'm going to show you now another example. This is a little more obscure. It's the Ta Prohm Temple in Cambodia. It's part of the Angkor Wat complex. And what I'm showing you here is a graph of the connections between images of Ta Prohm. And this is not from the web as a whole. It's from one particular user-contributed photo source. So each bubble here represents a photo taken somewhere in the Ta Prohm Temple complex. And everywhere that you see an edge or a link, that means that those two photos connected visually, so they saw something in common. And you get this really rather beautiful structure out. And as you can see, the dominant feature here is these two big clusters. One of those clusters are images that all look like this, but with a different person standing in front. And the other cluster are images that all look like this. And again, if you can make these beautiful movies where people, I should have brought one of those, where you see one person after another standing in this doorway, different lighting conditions, different times of day, and so on. So these are the two views of this temple that a lot of people shoot. And in this particular case, Ta Prohm Temple is small enough that there is actually just barely a connection from the front to the back and around again. So there's just barely enough imagery to connect the front of the temple to the back and to do some semblance of 3D reconstruction of the temple organically from those photos. But it's only just barely enough. And if you go and you do this in the larger of the temples in the Angkor Wat complex, you can't do it just from user imagery. There isn't enough, and they don't connect well enough. And that really brings us to this idea of trellis. So by contrast, when we first launched Photosynth in August of 2008, so Photosynth for the first time was a service that allowed users to contribute images in groups, in sets, and those sets of images are bound together on the user's own computer and uploaded. And the moment we did that, we found that that users began to make photo collections that reconstructed things like Notre Dame with better fidelity than what we could get from the web. So in particular, this was just within a couple of weeks of launch. We already had dozens of synths of Notre Dame Cathedral, photosynths of Notre Dame Cathedral. And this particular one with 404 photos launched the same month, so uploaded the same month we launched. 404 photos, 99% synthy. If you look at the structure of this imagery, you can see that it's not just a collection of random snapshots. It's structured. And the structure pans across the surface of the cathedral and goes around the corner. It has wide shots and it has close-ups. And based on that, you get this gorgeous reconstruction, which is better than what you can get from just mining unstructured imagery. So the moral here is that you need both trellis and grapes. And in this case, the trellis is actually supplied by the user. So I don't necessarily mean to imply that trellis has to be collected by companies and grapes have to be collected by users, but that's often the way it works out. Photosynth is rare in being user-supplied trellises, in effect. So this is how we collect our trellis on the ground. Let me now start looking at Bing Maps as it's live on the web right now. This is the Silverlight-powered new version of Bing Maps, and you can see that it's got lots of smoothness that's not typical of apps on the web. And the reason for that is that it's using deep zoom. It's using Seadragon. Now, when we dive all the way in, we're looking at an original aerial image. And so this is about as high resolution as it gets for aerial photography. We shoot from the air. We shoot both straight down and also obliquely at 45 degrees, and that's what gives you these lovely views of the facades. As we move from one photo to another, watch closely, and you'll see a kind of morph. And that morph is, of course, because when you're looking at aerial photos, every particular aerial photo was taken from one point of view. And so what we have here is a regular grid of photos taken from the air, each with its own point of view, and it's basically a photosynth. And in fact, these transitions between aerial images are very much photosynth inspired. They're using the dominant plane of the ground. They're using that geometry to make the transitions fluid and to minimize the jarring effect of moving from one point of view to another. Now, if we zoom out a little bit, then you'll see another transition, and that transition is to this unified perspective, which is taking all of those photos and stitching them together. Now, the reason that we don't show the stitched together view all the way down is just because we wanted to provide access to the absolutely raw imagery so that there'd be no lossiness whatsoever when you went all the way in. So this is a SimCity-like view at 45 degrees, where all of those photos have been stitched together, and you can look at this from different points of view. This is looking north, looking east, and so on. And again, those transitions use that dominant plane. They have the same sort of trick underneath. Now, if we drop down to ground level, we can see some of the sorts of trellis building that we're starting to do at human scale. Now, one of the things that you noticed as we dropped down is that you saw the geometry of the street as we went in, and that's because at street level, just using single dominant planes isn't really enough to give you an immersive sense of what's going on. So, or to bind the information adequately. So what we're doing here is we're using a much more complete geometry of the surrounding environment. We're exploiting a lot of the technology that Virtual Earth built up over the years of reconstructing three-dimensional buildings and such from these aerial photographs. We're using the same techniques at ground level to reconstruct the 3D. That's why if I click on a facade, during that transition, you see we're using the geometry to interpolate between these views. And so you get something that's really very close to a three-dimensional experience, while at the same time keeping a sense of total photorealism when you're at any particular spot we're pretty happy with how this turned out. So this is trellis collection now from the ground using this device, right? Which probably some of you have seen on the street. We're expanding our collection of this stuff greatly over the next couple of years. Now, we showed off for the first time at TED a few weeks ago an application called Streetside Photos, which is right now in beta, or this is a tech preview, I guess I should say. So it's a little bit like Photosynth when we first launched it, with just some canned collections of imagery. But what we did here was to mine Creative Commons geo-registered photos out of Flickr. And the thing to remember about these geo-registered photos, whenever you take a geo-positioned photo, its position is going to be off by a lot. So in a city, it's common for it to be off by 40 meters or even by 100 meters. And if you've positioned the pushpin manually, there's even an ambiguity in people's minds about whether they put the pushpin where they were standing or maybe across the water where you're shooting. So what we do is we start with the geoposition, and we then do a photosynth-like match of the imagery to the street side. So this is a photo from 1919, which matched to our street side imagery of the Pike Place public market before a bunch of these renovations. You can see that it matched because this building has remained pretty much unchanged over the past century. So this kind of locking together of imagery, in this case historic imagery, with the structured imagery is a great example of trellis plus grapes. And here in the Pike Place Market, it's kind of like Notre Dame. Many, many people have taken photos here. So there's a very rich, dense collection of images of the market. In fact, if you look at all of downtown, there's a pretty good collection of imagery downtown, and this is up for you to explore. In many parts of the city, imagery is starting to be dense enough with the number of uploads that people are making of geotagged photos that the grapes are growing thickly on the trellis, and you really can have a sense of a timeline or of user-contributed imagery really in many places that you go. But the gap from that to be able to do full 3D reconstruction from the photos alone is still large. And that's why we're going to need to really bridge the gap between that user-contributed imagery as individual grapes and the sense of trellis. The trellis right now is driven with this. As we evolve, we're starting to collect trellis with things like this, which are much more portable and can go indoors. And of course, as we go into the coming years, I think it's reasonable to expect that these things will keep on shrinking, keep on becoming more economical, more widespread. Will be able to be used in a wider variety of different contexts, and eventually will become cheap enough that we can just kind of paint the world with devices and get this kind of imagery anywhere we want. So much for ecosystem of imagery. I hope that through this particular case with the imagery, a few things are coming across. One is the need for combining that canvas, which registers everything together, with the content that comes on top, and which in some cases is trellis-like and in some cases is disorganized, and that disorganized content uses the trellis to bind to. Apps are a similar story. So one of the big transformations that we made in Bing Maps over the past year was to reconceive of this website as just a driving directions website, and think about it instead as a surface on which all of these different sorts of apps can live. If you think about it, spatial search and driving directions, routing, geocoding, those are all like trellis services. And here's a collection of our first grape-like and organic apps. So today, with any kind of luck, we'll be launching 3 new ones over here. One of them is the Bing Maps World Tour, which shows you our new imagery. I'm not going to pull that up because I'm a little mindful of time. One of them is from our friends at Foursquare. This one is especially cool. I'm going to pull up to get a really broad view of the world. And you can just sort of see all these check-ins, all these Foursquare check-ins dropping in all over the map as they stream in. So this is really really pretty fun. If you log in, then you can get a personalized feed from your own friends, and you can search across all of these and so on. There are all kinds of really cool things you can do with this Foursquare app. And the interaction here is richer. It's more interactive. It's richer. It's more fluid than what you can do with a regular mashup. The other thing that I think is powerful about this mash-in model relative to mash-ups is that here everything is discoverable in one place. So in effect, we're providing both the infrastructure and the binding for all of those things to connect together, as well as mechanisms for them to be discovered really easily. So in the mashup world, where everybody has to kind of get their own website and host it, and then bring tiles over from somewhere else, and so on, that's great for a lot of scenarios, but it doesn't allow that level of fluidity. It doesn't allow you to exploit all of the same interaction that you can get on the main site, and it also means that you have to kind of launch your own marketing campaign to promote your mashup. And with this kind of interaction, I think we can do better. So let's clear that one off. In fact, let's clear them all off. And let's pull up Oodle. So this one is showing rentals. So these are rental properties. Of course, I'm sure many of you are familiar already with the Oodle site. Oops. Okay. So here we've got all sorts of content streaming in, and we can browse it. We can browse it spatially. We can browse it based on filters or searches, and so on. So this again is all sorts of unstructured organic content being collected by Oodle and being mashed in to the map as an app. There's another app that I think I should show in this context, even though we've shown it off before, and that's hyperlocal content via this thing called Local Lens. This one is really interesting because Local Lens is a real-time crawl like Foursquare and like Twitter Maps, which we've also shown before. But the kind of content that is being crawled in the case of Local Lens is blogs, hyperlocal blogs that are written in a particular neighborhood to be read by people local to that neighborhood and about things in that neighborhood. And in this case, what we can do is we can extract. Actually, sorry, let me pull off these other guys and maximize Local Lens. So anytime one of these posts refers to a spot, even if that spot is ambiguous relative to the world, like 40th and Thistle, when we know that it's a hyperlocal blog and we know that it refers to a particular neighborhood in Seattle, in this case, we can disambiguate that. And the reason this is so exciting to me is because when you start to mine hyperlocal blogs and you're extracting this kind of entity information from these real-time streams, these are posts that this post is probably from today or from yesterday. When you're doing that in real time, then things like restaurants that haven't yet opened begin to show up in this kind of data feed, in this kind of data stream. Things like events that are happening right now. Maybe even impromptu events that are happening right now that somebody has just blogged or microblogged. These kinds of things show up in the real-time feed. So as we begin to weave that kind of organic material together into the services layer of Bing Maps, we're going to get a richer and richer sort of information substrate on which other kinds of apps can ride and exploit. So I think I'm going to have to end there. Thank you very much.